In this video, we'll talk about simplifying radical expressions. So let's talk about the theory of it. Let's talk about square roots first, because that's something we have a lot of experience with. So if we were to be asked, what's the square root of 9, I think we could all comfortably say that's 3, or potentially negative 3. But for now, let's just stick with just the positives. So what's really happening here is that we are saying, okay, this is the square root of 3 times 3. And basically we're looking for a square root is what number times itself makes 9. So 2 of these is equivalent to 1 outside of what we call the radical. That's what this little symbol is called. The square root symbol is called a radical. Now if we think of taking this to another idea, let's say we're looking at the square root of 20. Now we know that 20 is not a perfect square, therefore the square root is an irrational number. Perhaps maybe I can represent this with an expression that would be easier to work with. So I'm going to rewrite 20 using prime factorization. So I'm thinking we can write it as 4 times 5. First off, 5 is prime, so I'm good on that side. And 4 can be written as 2 times 2. So realistically, I could rewrite this as the square root of 2 times 2 times 5. And again, notice we have 2 2's. 2 underneath the radical would be the same as 1 outside the radical. So we could rewrite this as 2 times the square root of 5. This would be an exact expression where instead of having the square root of 20, we can say it's 2 times the square root of 5. It's a smaller square root expression that we have to deal with. And this is the governing idea behind simplifying radical expressions. Now the only difference is when you talk about a cubic root or a fourth root is that instead of having 2 underneath as 1 out, the number changes. So like a cube root would be 3 underneath as 1 out. A fourth root, 4 underneath is 1 out, so on and so forth. So let's look at another example. Let's look at one where we have some variables. We have the square root of 12x squared y cubed. Now I'm going to rewrite this using prime factorization for the 12 first. So we're going to make a little factor tree for that. I'm thinking 3 and 4 multiply to make 12. 3 is prime, 4 is not, so I'm going to keep going on that one. 2 times 2 makes 4. So that means 12 is equal to 2 times 2 times 3. Which means I can rewrite this radical expression as 2 times 2 times 3 times x times y times y times y. And now I'm going to go through. I have 2 2's, I have 2 x's, and I have 2 y's. That means I can pull out 1 2, I can pull out an x, and I can pull out 1 y. So ultimately I would have 2x y times whatever's left, which in this case is the square root of 3y. And this would be as simple as we can make it for now. Until we know what x and y are, this is as good as it gets. Now let's expand our thinking here. Let's talk about a cubed root. So notice this is what makes it a cubed root. Likewise, we have a fourth root, there'd be a little 4 up there. This is basically saying, okay, 3 factors are what's required to be able to pull 1 out. So again, I'm going to start with the number. Let's start with 16. Let's break it down to its prime factors. Well, 4 times 4 makes 16. Neither one of those is prime, but that's okay. I can keep going. So 2 times 2 makes 4. Also 2 times 2 makes the other 4. So 16 is equal to 2 to the 4th power. So we could rewrite this technically as 2 times 2 times 2 times 2 times x times x times x times x times x times y times y times y times y times y times y. Now you don't necessarily have to write them out every time. I'm just doing this to kind of illustrate what's happening here. And since we're talking about a cubed root, 3 factors is what's required. So I can pull out 3 of these 2's to make 1 outside the radical. I can pull out 3 of these x's to pull out 1x out here, leaving me 2 underneath, so those 2 have to stay. And then I've got 3 y's and also 3 more y's. So I can pull out a y and another y. So in essence, I'm pulling out 2x, y times the square root of whatever's left, which in this case is a 2 and 2 x's. So 2 times x, which we can simplify this a little bit for ourselves. So we can rewrite this as 2xy squared times the square root, or the cubed root, forgive me, of 2x squared. And this is our simplified expression for this radical. Now, like I mentioned before, you don't necessarily have to write out the long product here, this long string. I just did that to illustrate the example. You can go through and say, oh, 5, I can take 3 out, leaving 2 underneath. 6, I can pull out 2 y's, or a y squared, and there would be none left over. We could make that logical leap. We could even go from here, we could say, oh, 2 to the 4th. I can pull out 3 of those, leaving me 1 underneath the radical. And we can go with that thought and do exactly what we did to get to our solution. I'm just doing this to kind of show what's happening here.